Okay, let's talk about infinite limits. And to do that, we'll use this function, f of x equals 1 over x. Now, one of the things you might notice about this function right away is that it's not defined at x equals 0. And in fact, if you think back at your pre-calculus days, you may notice that there's a vertical asymptote there at x equals 0, because remember, vertical asymptotes occur whenever the denominator of these rational functions is equal to 0 and the numerator is not. Okay, so you've got a non-zero numerator and a 0 denominator. There's a vertical asymptote there. So in a way, we're not studying anything new. We're just kind of pouring some calculus on what you already know. So let's just analyze what happens as x gets very close to 0. So here I go. I've got x, and I'll pick some values. I'll start with 1, then go to 1/10, 1 over 100, 1 over 1,000. And then I will analyze the function at those values. Okay? So I'm going to say 1 over x, and I'm going to plug in these numbers. Okay? So here we go. If I plug in a 1 into the function here, I just get a 1. If I plug in a 1/10 in for x, I get 1 over 1/10. Well, that's 10, right? See? 1 over 1/10. I invert and multiply and get a 10. Likewise, this one would be 100. This one would be 1,000. Now, you see what's happening here. As x gets increasingly close to 0, the function 1 over x gets large and in charge. It just blows up. And in fact, no matter, you can use your imagination and think of any huge number, 1,000,000, 1,000,000,000, 1,000,000,000,000, down here for the function value. And you can always go back and find an x value that will give you that number. So I could pick 10,000. Well, 1 over 10,000. 1 over 10,000 plugged into this function will give me 10,000. 1,000,000,000, 1,000,000,000,000, whatever you choose. So here's the thing. No matter how big of a number I pick, I can always find an interval of x's that will give me numbers even bigger than that. Whenever that situation happens, that's when we talk about a limit involving infinity. So we have the limit as x goes to 0 because I approach from the right. I started at 1 and I went to 1/10, 1 over 100, and so forth. Whenever we have a situation like that, like is described here, we say the limit as x goes to 0 from the right of 1 over x is infinity. Yeah. Now we could go from the other way. We could say, well, what about the limit as x goes to 0 from the left? Well, just change all these x's to negatives, and you would change all these y's to negatives, and you would see that that's going to negative infinity. So we have an example here where we have a right-hand limit, infinity, a left-hand, negative infinity, and you might remember, what this graph looks like. If you sketch it out, you've got this asymptote over here, and then over here it goes down here. So it's going to negative infinity this way, positive infinity this way. So we're talking about asymptotes here. Now, so let's look at a function here. Let's suppose that we've got f of x equals, let's say 2 over x plus 1 squared, like this. Let's suppose we've got that function. And we want to talk about the limit as x goes to, let's say 5. Okay? So let's just suppose we've got this situation. Now, what you do generally when you're evaluating these rational function limits this way is, remember, you just plug in. So this would be 2 over 5 plus 1 squared, or 2 over 6 squared, which would be 2 over 36. 2 over 36, and I guess that would be 1 over 18. Okay? So, don't lose sight of that. I mean, having these rational functions does not mean you're always going to have something involving infinity. However, when we have this situation, let's suppose we have the limit as x goes to negative 1. Now, notice what happens when we try to plug in. When we try to plug into this bad boy here, we get negative 1 plus 1. That's 0. So we get 2 over 0. Well, that can't happen, right? You can't have 0 in the denominator. So here's what's happened. Notice, we take note of the fact that we don't have 0 over 0. If we did, maybe we want to factor and cancel or do some additional work to see if we could find the limit. But that's not what we have here. We have a non-zero up top and a 0 in the bottom. That tells us that x equals negative 1. See this negative 1? That's a vertical asymptote. Yep, that's a vertical asymptote. In other words, this limit is either going to be positive infinity or negative infinity. That's what this tells us. And what we need to do is we need to figure out, well, which is it? So one of the things we could do is we could just test it out. We could say, you could say, okay, here's my negative 1. What's going on to the right of this thing? And that would be the right-hand limit. Okay? Well, if you go to the right, maybe pick a 0 and test it in here. Well, I have 2 over 0 plus 1 squared. Well, that's greater than 0, right? That's 2 over 1. So that tells me it's going off to positive infinity. Now, also you could pick a number to the left of negative 1, maybe negative 2. But the thing is, you notice you're squaring the bottom. So it's always going to be positive. So this is going to be infinity. So we didn't have to do a left-hand limit and a right-hand limit. This was the right-hand limit, left-hand limit. Here, we were just told, find this limit. And we found it to be infinity. So whenever we have a situation like that, that's what we do. So let's look at another one. Let's suppose that we've got f of x equals, well, let's say 2 over x squared plus 7x plus 10. Something like that. Okay, so this is the function that we're dealing with. Now, we can talk about limits. We can say, well, what about the limit as x goes to 1? Well, I just plug in and see if that works. So I've got 2 over 1 plus 7, that's 8. So this is 18 right here, so that's 1/9. Okay, just plugging in there. See? Now, what happens though if I say the limit as x goes to, let's say negative 2? So I try to plug that in. Now, by the way, well, let me just do nothing yet. Okay, so let me put in the negative 2. So I've got 2 up here. I've got negative 2 squared. Whoops, negative 2 squared plus 7 times negative 2 plus 10. Okay, let's see how this looks. This is going to be a 4. Okay, look at this. This is 4 and 10. That's 14. And negative 14, that's 0. We get 2 over 0. That tells us we have stumbled upon a vertical asymptote. So whenever you know that, whenever you realize that that's happened, you can come over here and look at the factors. Okay? So let's see if we can look at the factors. This is going to be x plus 2, x plus 5. And we know that there is a vertical asymptote at negative 2. The question is, so this thing is either going to positive infinity or negative infinity. We need to figure out where it's going. That's what we need to do. Positive infinity or negative infinity. Now you can look at a graph and determine. But let's just examine this a little bit and see if we can figure it out. Now, we also know there's a vertical asymptote at -5. So let's see what the situation is here. We've got a vertical asymptote at -5 and at -2. Let's just check and see how the function is behaving between the asymptotes. So what I'm recommending is if you've got more than one asymptote and you're trying to pick values to test to see if it's going to positive or negative infinity, identify all the asymptotes, both of them in this case. So between -2 and -5, I'll pick a -3 to test. And on this side over here of -2, I'll pick a 0. Okay? Because I'm wanting to see really what's going on around the -2 as we approach -2. Well, notice that if I put in a -3 here, this is negative and this is positive. So I've got a negative times a positive. That's a negative. Okay. If I put in a 0, I get a positive times a positive, which that would be a positive. So look, here's the deal. This limit does not exist because the limit on the left is going to be negative infinity. The limit on the right is positive infinity. So let's see how this would look. The limit as x goes to -2 from the left of this thing, and to save space, I'll just put f of x, is equal to negative infinity. The limit, if we go the other way, if we say the limit as x goes to -2 on the right, that would be positive infinity. Okay? So this is an example where this limit actually doesn't exist because the left-hand limit and the right-hand limit are different. However, the one-sided limits do. The limit as you approach from the left, the limit as you approach from the right. Those exist.